Okay, this is the instruments. Yeah, electroscope. Yeah, an electroscope has function to detect the presence of electric charge. Yeah, the part of electroscope, yeah, such as brass cap, it can be neutral, positive, positive, negative, brass rod, and gold leaves.
Miss Daniel present, Miss.
Daniel present, okay. Daniel. Yeah, we can use this electroscope to detect the presence of electric charge. Yeah, how we can detect it? Yeah, for example, when we put the positive charge rod, the glass rod, positive charge rod, it will affect the gold leaf. The gold leaf differs. Yeah, why the gold leaf differs and what is the mechanism of electroscope? Yeah, let's learn first about the electric charge and also about the electric field. This is the learning outcome today. At the end of this lesson, you should be able to describe and to state what an electric field is. And also, you should be able to draw electric field patterns. And then, let's review the force between two charges. Yeah, for example, we have positive and positive charge. Like charge, positive and positive, negative and negative charge, and the last, the opposite charge, positive and negative charge. Yeah, can you guess what is the force of attractions between the two charge, positive and positive, negative and positive and negative? Do you still remember about that? It will repel or attract for positive and positive. Yeah, positive and positive. Yeah, repel. Yeah, repelled, 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 and positive and negative. Yeah, will attract each other. Will attract each other. So we can make the conclusions. Yeah, the like charge repel each other. The opposite charge, positive and negative, attract each other. Yeah, why the positive and positive repels? It because the presence of the electric force. Yeah, because the force electric, that known as the electric force. This is the direction of the electric force. And for the negative and negative, same as the positive and positive. And this the force of positive and negative. Yeah, the force is experienced without the change, without the charge being in contact with each other. Yeah, this without being in contact for the electric force. So we can make a conclusion that electric force is the attractive or repulsive force that electric charge exert on one another. Next about the electric field. If we place small positive test around a positive charge, what will happen? Imagine we have the positive charge, and then we also have the another small positive charge and positive charge. What would happen? Positive and positive. So this is the directions of the electric force. We know that the positive and positive repel each other. It's why the direction of electric force will be like this. Repel each other. Now we can draw, repel each other. The positive and positive. Yeah, this is the direction for the electric force. So we can draw the electric field lines, of a positive charge. It will be like this. This is the positive charge. This is the arrow that represents direction of electric force. We can conclude that the direction of the positive charge, directed away from a positive charge. Directed away from positive charge. If we place small negative, this negative, small negative test around a negative charge, what will happen?
Repel.
This is the, it's positive.
That one is positive.
It's positive, I'm sorry, positive. Same charge, positive. So sorry, this positive. This positive, same. The test charge is positive. Positive, positive, positive. So the direction of electric force, it will be from the positive to the negative. This is the direction of electric force. From positive to negative, from positive to negative. So we can conclude the electric field lines of negative charge. It will be like this. We can conclude the electric field lines are directed toward from a positive charge. Are directed toward from a positive charge. Electric fields, is a region in which an electric charge experiences an electric force. We can show electric fields by line with arrow. The arrow represents the direction of electric force. This is positive. Goes away from the positive charge. Goes away from positive charge. But when the positive charge, the lines, will toward the negative charge. Toward the negative charge. And how about the strength of electric fields? For example, we have the charge Q. This is the arrow that represents direction of electric force. 1, 2, 3, 4, 5, 6, 7, and 8. What about if we have charge 2Q? 2 times Q. How about the arrow? It will be also 2 times the total number of the arrow. Because more charge, it means more electric fields. So represent by the more the arrows. For example, in this area, further field lines, means weaker electric fields. And then for this area, closer field lines, stronger electric fields. Closer, it means stronger the electric fields. Further field lines, weaker the electric fields. Okay, can you draw the field lines for 2 charges together? When positive and positive if two charges, positive and positive. Okay, let's withdraw. How about positive and positive? The arrow will go away from the positive. Go away from positive. Go away from positive. Go away from positive. How about negative and negative?
Oh, attract, Miss.
Attract, negative and negative? It will
I mean the same, Miss, as the first one.
repel as the positive and positive. Yeah, it will, yeah, toward the negative charge. Directed, yeah, are directed toward the negative charge. Directed toward the negative charge. Yeah, how about the positive and negative? How about the arrow that represent the direction of, yeah, will attract, yeah? How about the arrow? From positive to negative or from negative to positive? Because the charge go away from the positive, go away from positive, yeah, it means the arrow will be to the right, from positive toward the negative, from positive toward the negative. That's why we be like this, toward negative, toward the negative charge, toward the negative charge, and go away from the positive charge, go away from positive charge. This is the picture that represents the electric fields of positive positive, positive negative, and positive negative.
Miss, the arrow always 3, or we can draw how much we want like that.
The arrow,
Like we can only draw 3 for each
it
charges.
based on the charge, total number of the charge. More charge, it will be more arrow. Because more charge means more force of attraction. Based on the total number of charge.
Okay, Miss.
Okay. And how about the electric field lengths of parallel plates? Yeah, this is from two parallel plates, positive and negative. Yeah, we know. Yeah, go away from positive and towards the negative. Go away from positive and toward the negative. So we can conclude that electric field lines start from positive charge on one plate and end on negative charge on the other plate. And then let we see at the central regions. It is the central regions. The electric fields, yeah, between parallel positive and negative charge, yeah, is uniform at the center regions. Uniform. Okay, this is about the electric fields. Any concern about the electric fields? No. Can we continue to the simple questions? Yeah, in the diagram below, yeah, P is a point near and negatively charged. Yeah, which direction best represent the direction of the electric fields at point P? Yeah, you can see, you can send your answer, yeah?
Miss, I don't understand.
Huh? This negative charge. How about the direction of the P? It will be like this, to the right or to the left, up or down. Which one?
Right is kanan, right, Miss?
Yeah, right. It's right, okay? Right, left, down, up, down, right, left. Am I right? Left, right, up, and down. Okay, Jesslyn, correct. Number 1. You don't forget to write the subject, yeah, and the date today. Wilson, okay, correct, Wilson. Jennifer, correct, number 1.
May send to private message.
Yeah, Jeffrey, correct. Louis, correct. Leon, correct. Okay. Kenny, okay, can we continue to the number 2? Kenny, please send your answer, yeah, Kenny. Number 2. Yeah, at which point is the electric field the strongest? Daniel, correct. Bilton, correct. Wilson, correct. Jesslyn, correct. Daniel, correct. Leon correct number 2. Niken correct. Jeffrey correct. Jennifer correct number 2. Louis. Come on, Berlian. Number 2 yang Berlian. Okay, correct. Next ya, number 3. Yeah, at which point is the electric field the weakest? Daniel, correct. Jesslyn, correct. Jennifer, correct. Berlian is answer number 1 ya. Ya, Berlian. Right, left, up, or down? Come on, Jeffrey, Leon, Niken. Number 3. Jeffrey, correct. Number 3. Kenny, answer number 1 and number 2 ya. It's number 1, Kenny. Niken, correct. Number 3. Leon, correct. It's number 1, Kenny. It's number 2.
Miss, can you back to number 1, Miss? Wait, miss.
Number 1, okay. It's number 1. Dan Kenny number 1?
Dan, Miss.
Ada number 2 ya. Number 2 Kenny. Correct, Kenny. Number 1 and 2. Next number 4 ya. Yes, Lynn, correct.
Miss Daniel correct or not, Miss?
Daniel. Daniel. Daniel incorrect, Daniel. Number 4 ya. Incorrect. Berlian correct. Niken correct. Jennifer correct. Kenny correct. Jeffrey correct. Leon correct. Bilton. Number 4 Bilton. Bilton and Louis. Okay. Wilson correct. Last ya, number 5. This number 5. A and B are both positive. A and B are both negative. A positive, B negative, or A negative, B positive. Incorrect, Daniel.
Miss, how about mine?
Berlian correct. Bilton correct. Kenny correct. Number 5. Jennifer correct. Niken correct. Bilton, Kenny correct. Number 5.
Miss, how about mine?
Jesslyn ya? Jesslyn. Correct. Number 5. Leon correct. Come on, Wilson, Louis, Jeffrey. Jeffrey correct. Louis and Wilson. Louis correct. Last ya, Wilson. Wilson correct. Okay, let me discuss. Start from number 5. Yeah, what is the answer for question number 5? Yeah, the arrow. Yeah, from A to B. So we can conclude the A is positive. Because electric force, yeah, always go away from positive, yeah, toward the negative. That's why the correct answer is C. A positive, B negative. Next, number 4. What is the answer for number 4? Yeah, go away from B. Yeah, so we can conclude B is positive, and towards the A is negative. So C is the correct one. Number 3, yeah, at which point is the electric field the weakest? What is the best answer? Yeah, C is the weaker. Because the field lines are farther apart. Number 2, yeah, which point is the electric field the strongest? Closer the lines, yeah, stronger the charge or the electric force. Yeah, so B is the strongest point. Number 1. What is the answer for number 1, Wilson? What do you think, number 1, Wilson? Wilson Lau?
It is.
Huh?
Answer is left.
Left. Why left?
Because the negative is in the left.
Yeah, negative is in the left. And then the electric charge, yeah, the direction of the electric charge always towards the negative. Yeah, it's why left. Okay, that's the answer of number 1, left. Okay, done, yeah? Okay, let's end this meeting. Thank you for your participation, dear students. See you later. Bye-bye.